Hey guys, Professor Benson here. I'm taking a little bit different approach with this one. I've given you some worksheet that you should download so that you can follow along and actually work this out. As you'll see over here on my right, I've got ones that I've already worked out, or these questions I've already worked out. I'm going to work them out with you right now. So why don't you go ahead and pause the recording. I will go ahead and put in a break, but pause the recording and then download it, and then I'm going to go ahead and walk through this, and then I will show you how to do this in Excel. And I'm going to show some formulas here. I'm going to show this in the actual spreadsheet as well, but just keep in mind there are sort of four formulas that we're going to end up using here. And so the first one, I say I have a z-score. I need to find the percentage of observations below that z-score. I'm going to use this formula here called it's called norm.s.distribution. The S in the formula stands for the standard normal distribution, which just standardizes it with a mean of 0 and a standard deviation of 1. I have the probability. I need to find the corresponding z-score. For example, how many standard deviations above the mean capture 80% of the observations? And here we're going to use something called norm.inverse. So this is short for normal, and it's norm.inverse and or norm.s.inverse. And so if you use this first one, you'll need to put in the 0 and the 1 for the mean and standard deviation. If you use the norm.s, it just puts it in for you. The next type of questions are, hey, heights of men, and this is the ones we'll actually do, are normally distributed with a mean of 69 inches and a standard deviation of 2.8 inches. What is the height below which 90% of the men fall? And I could do it. I could find the corresponding z-score and then figure it out. I'll show you that. Or we could just plug it into this norm.inverse function. And then I have a height. I need to know, or I need to know how many men in the population fall below that height. So for example, assuming the same 69 that men are on average 5'9", that's 69 inches, and with a standard deviation of 2.8, what percentage of men are less than 72 inches tall? And this is the formula that we'll use. Okay, and a lot of this is based on the fact that if 0 here is going to be my mean, okay, and then 68.3% will be plus or minus 1 standard deviation around that mean. 95.4% will be within 2 standard deviations of the mean, and 99.7% will be within 3 standard deviations. And of course, if I wanted to do what's on the how many are less than 1 standard deviation above the mean, I would take, so 50% are going to be less than this, and then I would do 50% plus this 34.1%. So 84.1% are less than 1 standard deviation above the mean, or I could write mean plus 1 standard deviation. Okay, so I have my answers that I've already worked out over here on the right. I'm a left-hander, so I'm going to work here on with my left hand. Okay, so I've got for this one, we're going to assume that men are normally distributed with a mean of 69 inches, so they're 5'9" with a standard deviation of 2.8. And then later on, women are 64.6 inches tall. That's 5'4.5", or just above that, with a standard deviation of 2.5. And this is actually pretty close to the real deal. I've seen different numbers. If you Google it, you'll get something around that, but that is the number that you'll get. So these guys make day beds that are 75 inches long. And these are actually practice tests for the AP statistics test, believe it or not. And they say find the percentage of men whose height is less than the height of that 75-inch bed. And a day bed, you can go Google these. These are beds that look like a couch during the day, but they're long enough that you could sleep on, or they'll have a drawer underneath that you can pull out. So what we know is, if I go ahead and mark this up, if I go ahead and put down here, so for men, okay, this is 69 inches, and we need to find 75, which is probably going to be somewhere over here. We need to find what percentage of men. So if we just say this is 75, and I put these normal distributions here so you could evaluate what we're looking for. What we're essentially looking for is what percentage of the population is in this area that I just shaded in red, so less than 75 inches. And there's a couple ways we can do it. The book is going to write this as the probability that x, meaning the height that we're looking for, is less than 75 inches. And so the z-score route says, look, a z-score is just how many standard deviations above from the mean am I, above or below. And so the formula is the value I'm looking for, so in this case 75, minus the mean. So in this case, this person is that's 6 inches above the mean. And is 6 inches a lot or a little? Well, if I normalize it to the 2.8 inch standard deviation, it's equal to 2.143 if I do that on my calculator, or in Excel, standard deviations above from the mean. So that's a lot, right? On our earlier sheet, we saw that 2 standard deviations above the mean is going to be this. Is going to be 84.1% plus this 13.6%. So we're already in the 97, 98% range. Okay. Using Excel, I'll just write this in here. You're going to use the norm, and I don't expect you to remember this right now. That's why I put those formulas in the in that table. Dist, and so then it's going to say the 75. That's what we're looking for. 69 inches, that's the population mean. 2.8, that's the population standard deviation. And then we're going to say true, which means give us the cumulative. And I'll go ahead and just pull this here. The cumulative probability, which means if I start here and add all the area up under that curve, or add everything up till this point, what's that percentage? And so then, again, this 75 says the height we're talking about, 69 population mean, the 2.8 population standard deviation, and then this is the cumulative probability. Is that true? Sorry, we set that to be true. Okay, 2.143. So I put up here a z of 2.143 means that 98.4%, and I'll show you how I found that in a minute in Excel or using the table, or there's about 3 different ways we could find this. 98.4% are below this 75 inches. Okay. In the second question, I said, okay, given your answer to number 1, so I'll go ahead and rewrite that here. I've got a z of 2.143 means 98.4%, or it'll actually spit out to you 0.984. It's probably 9839 or something like that, are less than 75 inches. So then the next thing would be, okay, how many would be, if 98.4% are below, less than or equal to 75 inches, how many are taller than 75 inches? So how many are in this right tail over there? And the answer, of course, is, well, it has to add up to 100%. So if I do 100% minus 98.4%, you can see it right over here because I've written it right here. If I've got 100% minus 98.4%, I've got 1.6% of men are greater than or equal to 75 inches. Now, the next question says, what about for women? Now, the women are much shorter, or are shorter on average, right? They're 64.6 inches. Okay, and so that if it's way over here for the men, it's going to be way, 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 way over here for the women, and so we're gonna end up including all of this, and the mean here for the women is, what is the mean? 64.6. So we would do it the same way. The z-score is equal to, what do we have here? We've got 75 inches minus 64.6, and I changed it from here, and I'll show you why in a second, with the standard deviation of 2.5. And that is going to equal, let me go ahead and pull up where I calculated that. Okay, so 75 minus 64.6 is 10.4, right? We do 75 and 64.6 minus, okay, so that's 10.4, and then when we divide that by 2.5, we get 4.16 standard deviations above the mean, or the z-score. Okay, that's going to differ than what I've got right here, because at that point I was using 63.6 for the mean for women. Okay, now we know that's going to be super high when we plug that. When I just plug that into each of the formulas, I got that a z-score of 4.16 is 99.998%. So 99.998% of women fall below 6'3". Okay. Now the next one says, look, if in designing this new bed, I want it to, I want 95% of men, and because the men are taller than women, I want 95% of men to be able to sleep in it, like they're not too tall for it. So the 95% is going to mean a z-score of, and I just happen to know this, but you can use the formula, this very first formula, or this next one to say what's the z-score that corresponds to 95%. But a z-score is going to equal 1.645, just because I know what that is. So now what we need to find is what height is 1.645 standard deviations above the mean. Now, there's two ways I could do this. The formula to find that is I would use norm dot inverse, and I could do this at 0.95, and then I know that the height of men on average is 69 inches, and the standard deviation is 2.8, and it would spit that out. But we could also do it, this is the old-fashioned algebra way, which was you could say, so x, we're going to solve for x minus 69, and divided by the 2.8 standard deviation is going to equal 1.645. So then I could move stuff around and say, so if I multiply both sides by this 2.8, then I'm going to get x minus 69 is equal to 1.645 times 2.8, which happens to be 4.606. And then if I add 69 to both sides, so x is now equal to 4.606 plus 69 is equal to 73.61. Okay, and that is the value. 73.61 inches is the value under which 95% of men fall. So you would make your bed, say 73 or 74, but you'd want to make it at least 73.61 inches. So again, we're capturing, so wherever 95% is, we want all the men and women who fall into this range to be able to sleep in the bed. And we can double check our work here, because up here we did 75 inches, like this is going to look a lot like these two, and 98.4% of men fell under 75 inches, and so if we back it off just a little bit to 73.61, we've got that 95% fit in this range. Okay. Now the next question, this part of spurred this. I saw an article this week. It literally changed on May 13th. The Air Force changed the height requirements. Make sure you can still see this for pilots. Until this change in May, pilots had to be between 5'4", which is 64 inches, and 6'5". So 97% of men probably fall in that range, because this was designed by men, for men by men. But we're going to focus now on, they dropped that restriction because they wanted to attract more female pilots. So we're going to focus on how many women were excluded because you had to be at least 64 inches tall. And to bring over recall that the mean on this page is, or the women are 64.6 inches tall on average with a standard deviation of 2.5. So essentially what's happened, this blue line is the 64.6, this red line is the 64, and so everyone in this side of the line, all the women on this side of the line were excluded because they were too short, and I'm going to put too short in quotes because you have power seats on cars to raise them up or lower them, and an F-22 costs $1 billion, or an F-35. That one's had huge cost overruns. Those ones are super expensive. You can have power seats that adjust, or the thing, and they can be commercial pilots. So it works. Now, but the point here is similar to what we found before. Now it's, once we know the right answer, like everything is obvious once you know the right answer. So we're just going to do it just like we did before. And I have it set up right. I'm going to move this out of the way, but because on this one it was at the bottom of this page. Okay, but again, we can find the z-score, or I could plug it into the normal distribution, or the norm.dist, this function, right? We can say 64 minus, in this case, 64.6 divided by 2.5. So that is now going to equal, now this is a negative point, this is a negative 0.6. We're going to divide that by 2.5. And the answer there is, if we go ahead and do this again, we're going to say 64, enter 64.6 minus. So we've got this negative 0.6, 2.5 divided by is equal to negative 0.24. So they're 0.24 standard deviations below the mean. And then I could also put this in as, so I could find what's the probability of that, or I can also find, I could do normal distribution. Okay, and I'm going to do, we're looking for 64. The population mean is 64.6. The standard deviation is 2.5, and we put in true. Okay, and when we do that, I'm going to go ahead and pause and plug that into Excel. So I plug that into Excel, and the answer is 0.405. So 40.5% of women were excluded because they fell into this range. Okay. Now, in the article, you'll see they calculated 43.5%, and that just depends on what they used here as the mean and standard deviation for women's heights. So we're very, very close to there. Okay, so now on the final one, what I want you to do is, I'm going to go ahead and move this out of the way. Okay, which is what I want you to see is the next type of question that the book or others they try and throw off at you is, hey, what percent of women are between 5'2", so 62 inches, and 66 inches. Okay, so what you can see is, and this is the way we're going to do this in Excel, but I want you to be able to see here, the reason I drew this out and put these normal curves here is I wanted you to be able to see, to be able to visualize this, which is the way you're going to solve these is you're going to say, well, look, I'm going to find what's the probability that x less than 66 inches, okay, whatever that is. So all this range here to the left, fill this all in, okay? And then I can find what's the, so we would do the same thing. I'm just going to set up the z-score so we can see it here, but you're going to say, look, 60, this is going to be above the standard. In fact, this is going to be about, this is going to be just under a standard deviation, 66 minus 64.6 divided by 2.5. And then this one is, we'll get whatever probability this is, and I'm just going to plug these into this formula for each of these. But I think you can see, so this one is going to be 62 minus 64.6. divided by 2.5. So that is almost exactly one standard deviation below. So this will probably be 50% minus 34%. So somewhere around the 15.5, 16% range. Okay, and then you're just going to subtract these, because if I bring this guy down, right? If I take this colored area and subtract off this colored area, now I'm left with this area in the middle, which is what I'm trying to figure out. Okay? And so if you've done this, okay, so this is half a standard deviation, 0.56 standard deviations above the mean, and this is actually 1.04, so just over one standard deviation below the mean. And so for this one, 71.23% of women are less than 66 inches. And then down here, with that z-score, 14.92% of women are in this red range here. So it falls off pretty quickly once you start going towards the tails. Okay, and so now if I bring those down, I get 71.23% minus 14.92%, and Excel tells me that is 56.31%. So you'll get something around there depending on your rounding or how many decimal places, but the book normally says do 4 decimal places, or, so this would be 0.7123 and this would be 0.1492. And they're trying to find, in this case, this region. I'll go ahead and fill this in with this green. But 56.31% are in that green area, okay, between 66 and 62. Okay, so I've given you now some questions to do without my help. I will post the solutions, but these are all about the IQ. So let me show you those.